In chapter 13, we moved from kinematics into kinetics, or in other words, we began to connect the movements of a particle to the forces acting on the particle. And a couple quick mechanical things to review. First of all, you guys all know how to do vector addition. Let's say I had multiple forces. Let's say that these are some force 1, some force 2, and some force 3 as vectors. If we added all of these things up, we would get some resulting force. Let's call that F sub r. So we need to know how to add vectors, and we also need to know how to project vectors. We might have that same resulting force, F sub r, and need to split it up into components that go along with our coordinate system. So just to make up some generic coordinate system. Let's say that we have some coordinate system with one basis element u sub 1 and another basis element u sub 2. So of course, this little critter right here would be the resultant force as projected into the u sub 1 direction, and this little critter right here would be the resultant force split up into the u sub 2 direction. So if you're comfortable dealing with adding and projecting vectors, then really all chapter 13 was about was taking and writing Newton's second law into each of my directions. So just to be generic about this, these u sub 1, u sub 2, u sub 3, this might be x, y, and z. This might be normal, tangent, and binormal, or this might be the radial, the theta, and the z direction, depending on the coordinate system. So sum of forces in my first direction gives me mass times acceleration in that same direction, that same u1 direction. Likewise, sum of forces in the next direction will give me acceleration in that direction. On to the third component. So really, the key thing in solving these problems was to take time to draw a free body diagram, make sure you've got all your forces. Remember, in the free body diagram, the question is, what are the forces on me, the particle whose kinematics we're interested in? And we also briefly discussed a few key forces. So forces associated with gravitational pull, forces associated with springs, and forces associated with dampers. And I guess we did also talk about another type of friction. We talked again about Coulomb friction. So don't forget how to work with each of these types of force. That's pretty much it for chapter 13. Go back and look at homework and so on, and I think you'll find that really everything you did comes down to just going through these few points. In the next video segment, I'll do a quick review of chapter 14.